Hello, good evening, everybody. Welcome to another session. This is going to be a last session today for the month of Feb. So let me just quickly set things up. Okay, so we are going to get started. All right. All right. So this workshop that we are having today is basically a consolidation of what we've done in the last 17 sessions. So this is session number 18, where I try to bring in all the concepts that we've learned together in one place. So we're going to have a 1 hour session today. And I know most of you would be probably listening this as a recording. So I'm going to get started right away. Before that, I just want to introduce you to a feature in the Unacademy portal. So first 5 minutes, let me just, for those who are new to Unacademy, let me just introduce you to basically, I want to introduce you to Ask a Doubt feature. I think you should definitely explore that. So I had a couple of slides on it, so I just wanted to kind of quickly, yes, there we go. Yeah. So Unacademy Ask a Doubt. Ask a Doubt is a feature that's available for everyone on the Unacademy platform. By everyone, what I mean is it's available for both subscribers and non-subscribers. So all you have to do is log out to the portal. Of course, sign up on the portal. There is a section where you see Ask a Doubt. Take a picture, crop it if you want a specific, if you want only a specific portion of whatever you clicked, and then sit tight and send it out. And of course you'll have to choose the subject under which it falls and sit tight and you will receive a solution soon. So isn't it a great feature? I mean, it's just something that's available for you at any point in time. You can ask that doubt, and of course you will get a response back, not instantly though. It has to be processed by one of the educators. They will review and get back, but you should be reasonably it should be reasonably fast when you get back a solution. So I mean, in today's time, it's very relevant. I think make use of it. Make use of all resources that's available to you, and then to help you achieve your goal. So that's about quickly on Unacademy Ask a Doubt. Let me just move forward to today's workshop. So I'm going to come back to my slide here. Yeah, and then we will then go from here. Okay. All right. All right, here we go. So, I mean, as usual, the Unacademy Plus subscription, Iconic subscription are all available. Do check it out on the portal. And of course, there's Creative Corner subscription as well. Do check that out. It's got great features, great content that will help you achieve your goals. Okay, so let me quickly get started. Of course, for the month of Feb, there's a 10% off on all these subscription. Today is the last day for it. Anup YT10 is my subscription code that should you want to use it, should you want to refer to it if your family and friends. Okay, so just to take note of that code, Anup YT10. All right, so let me quickly get started. Okay, so these were all the topics. So pretty much a lot, right? I mean, if you look at it, there's a lot of topics that we covered in the last 17 sessions. If you have not got a chance to go through them, please visit some of the earlier videos, and then you should be able to replay that. So should you need to kind of revise your concept. But again, this session is meant to do that also to an extent. I'll help you. We're going to solve the problems, and then let me see how we take that forward. Okay, so first topic here is 2 and 3 digit multiplication. So let's go and look at a few problems. 2 by 2 digit multiplication. So if you remember now, for a 2 by 2 digit multiplication, we use the vertically and crosswise sutra, right? So by vertically and crosswise, so what we're going to do, we're going to multiply this last 2 digits here. So 20, right? Then crosswise, so it becomes a 10 plus 16, which becomes a 26, right? And then this is a 4 and 2, which is a 8. So your answer is 1080. Okay, let's look at another example. 42 into 56, 6 into 2, which is a 12. Then you do a cross multiplication, right? Let me do one thing. Let me try to take out my crosses wherever I'm putting it. So right now I've done this, right? This is what I did, and this is what I'm going to do now, right? So I did this. So 6 2s are 12, right? Yeah. And then when I do my cross multiplication, it is 24 plus 10, which is a 34, right? Remember, I'm writing, there's only one digit allowed. The second digit, the first digit that goes as part of the carry, and we'll handle the carries. Okay, just like how I did here. I added the carries here, added the carries here. That's how I got this. Okay, so what did I get? 10 plus 24, which is a 34, and then 5 into 4, which is a 20, right? So what is the answer? 2 3 5 2, right? 42 into 56. So 6 into 2 is a 12, right? 6 into 4 is a 24 plus 10, which is a 34, and 5 into 4, which is a 20. So 3 gets added here, becomes a 23. 1 gets added here to 4, which becomes a 5. So that's how your answer is 2352. So pretty easy to do this 2 by 2 digit multiplication when you use the vertically and crosswise sutra. You're doing it in one single line. The idea in Vedic mathematics, as I've always said, is to handle single operations and do it in the right sequence. This is the best sequence to do, instead of following the other sequence where you normally do, you multiply this units place by this units place, then this tens place by this ones place, then you multiply this by this. You're going to get the same result, no doubt about it. Then you multiply this ones place by tens place, and then finally you multiply these the tens place. So here what we are also doing the similar thing, just that if you see here, you're multiplying a units place by units place, you get your units place. So your units, tens, hundreds, right? So this is how your goal is to get the digits in these places, and that forms your answer. So when you multiply a units place by units place, you get the units place, right? Then when you multiply the tens and the ones, both of them, you're doing your addition then and there, right? You're doing your addition then and there, right? Then you get your tens place, because you're getting your tens into ones will always give you tens, right? Plus another 10. Now when that 10 exceeds and becomes 100, that's when that carry comes. Okay, remember that. Okay, you get your tens place. Then when you want to do your hundreds, you multiply your tens and tens, you get your hundreds. So that's how you do this vertically and crosswise sutra, details of which are on the earlier slides here. Just the intent is to do some practice exercises. Okay, so let's do another one. This is a 3-digit multiplication. Now remember the pattern for a 3-digit multiplication. There are a couple of steps here. Just draw these 3 dots indicating the 3 digits. And how do you so your first operation is this, your next operation is this, right? Your next operation is this, then your next operation is this. You'll have to do one more. Your last operation is this. Last operation is this. So that's how you do it. If you follow the same method here, you will get your answer, right? So 4 into 5 is a 20, right? That's the easiest, right? So 5 plus 8, which is a 13, right? That's also clear, right? Your next step is 10 plus 16. 10 plus 16, 26, plus 1 into 2, 26 plus 2, 28. Then you do this operation. 2 into 2, 4, plus 4. 2 into 2, 4, plus 4. 4 into 1. So what it is? 8, right? And then 2 into 4, which is a 8. So what's your answer? Final answer? 88 gets added here. 88 gets added to this 2, that becomes a 90. This 1 gets added to 8, that becomes 9. This 2 gets added to this 3, which becomes a 5. And the 0 stays like that. This is your answer. See how easily you're getting it compared to doing it, all that individual steps and doing that addition. Let's do one more, right? 2 into 6 is a 12. Next step is 4 into 6, 24, plus this will become a 0, so it's only 24. Then 3 into 16, 3 into 6, 18, plus 10, 18 plus 10 is 28. This will become a 0. Next step is this, 3 into 0 is a 0, 5 into 4, 20, and then 1, 5. See, if you get it in this state, your answer is almost ready, right? 1, 7, 2. Now here, notice another one, you're getting a 10, right? So 8 plus 2 is a 10. So we'll handle that. So that 10 will go here. This will become a 3, 0, 5, 2. This is your answer. Okay, so just repeating those steps here. The first one, cross multiply. When you have the 3 digits, handle those 3 digits, do that entire cross multiplication and the middle digit, then the cross multiplication, and then finally that last digits that you multiply. Okay. All right. Okay, so that was quickly on 2 by 2 digit, 3 by 3 digit multiplication. Now remember, there's also, when you do multiplication, if you're getting a number 23 into 141, you can consider this as 3 digits as well, right? Because you can always write it as 023 into 141. That's a 0, it makes it all easier to do the calculation. You can still perform the same operations that we did before, right, for 3 digit multiplication. All right. So you got a lot more to cover. So let me just quickly move on to the next one, base multiplication. Now remember what I told you about base multiplication if you have seen some of my videos. Now of course you can follow the sutra for the simple cross multiply that I told, but sometimes you will have situations where you can also choose, and sometimes different methods are there in Vedic Maths that help you sometimes get your answer even better and it's easier. So this is called the base multiplication method. In this case my base is equal to a 100. Okay, suppose my base is 100. The very first thing that you find out is how much it is less than 100. So it's a minus 2, right? It's minus 2 less than 100, and this is a minus 1 less than 100, right? So your simple operation that you have to do is first find out the product, add these two together. The reason I'm saying is add because you have a minus sign. So when you do a add 98 minus 7, 1, you get a 97. That's the first part of your answer. The second part of your answer is you multiply 2 and a 1, right? What do you get? Minus 2 into minus 1, you get a 2. Now this is a base of 100, so you can't really write a 2 as just as a 2. You have to write it as with a 0, 9702. That's your answer, right? So easy, right? So let's look at another example. Here also the base is 100, but here now it is 2 times 2 plus more than 100, right? So now I follow the same thing. 2 into 3 is a 0, 6, and when I add these two together, see, you can add these two or these two together, anything gives the same result. See, 98 minus 1 is 97, 99 minus 2 is also 97. So what do you get when 102 plus 3? You get 105. So which is your answer? So that's very simple base multiplication method, even easier than your vertically and crosswise. But of course you can't use it if the base is too far away, if the number is too far away from the base. So you have to make a choice. Sometimes it's okay. I mean, you can maybe calculate it, but then you will have to choose. You'll have to see and think for yourself, which is, is it too far away from the base? For some people, it's really difficult to define how far is far and how near is near. But try to. You will see that it comes with practice, getting used to it. Each one has a different different parameter. Okay, so let's look at one more example here. Now, in this case, this number is one number is greater than the base and the other number is less than the base, right? So here it's a +2 and here it's a -4, right? You agree with me, right? The base is 100 itself. So it's a +2 and a -4. Now I can either do 102 -4 or a 96 minus 96 +2, right? So the first part of my answer, I will do the easiest one, right? So doing a addition is easy. So 96 +2, I know first part of my answer is 98. Now if you see here, there's only one thing that you have to see. You're doing a plus into minus, right? So you will get a minus sign. So your answer is 08 with a minus sign. Now see, you got to handle this minus sign, right? So how do you handle this minus sign, right? How do you handle a minus sign? You got to convert this minus into a positive. So this minus, if you have seen some of my early videos, you'll be able to know it's a bar, number, or vinculum. Converting this is equivalent to 9 and 800 minus 8. This is equivalent to that, right? So this is 9792. Right, this is the answer actually, 9792. How you represent this is 8 minus, it's a base. See, if you have seen some of my earlier classes, you would see that I can represent 59 as 6 bar 1, which is called 60 minus 1, right? 58 can be represented as 6 bar 2, it's also called 60 minus 2, right? This is an easier way of representation in Vedic maths because sometimes you don't want to deal with big numbers here, and then it's easier to deal with a negative small number, right? But yeah, of course this units place will increase by 1, but that's still okay, right? So that is why, if you look at this, if you compare it here, there are two numbers here, so it's basically a base of 100. So 800 minus 8, that's your answer here. So that's why it's 9792. So let's look at one more example. This is a +4, this is a -8. See that? Is -8. So I either do a 92 + 4 or 104 - 8. I will do a 92 + 4. I consider that easy, and then this will become a 32 bar. So what is the answer here? It's actually basically 9 and 600 minus 32, which is a 9568, right? 600 minus 32 is 568. So answer is 9568. Right, so that's how we use bar numbers. It's a beautiful concept. It helps a lot in Vedic mathematics, especially to use base and bar numbers and all that, and make your calculation easier and faster. Okay, so we have covered the second topic as well. So this is a quick recap, quick refresh, also at the top, the concept, and also a few practice examples. That's what we're going to do today. Okay, all right. Let's look at special multiplication by 11, 101, 99, 999. This is also easy, right? So when you want to multiply by 99, it's a unique property that you have here. What you simply have to do is, see this part 24, reduce it by 1. That's the first part of your answer. And the second part of your answer, let me just draw a line here. The second part of your answer is 99 minus 23. So what do you get? 2376, right? This is your answer. So first part of the answer, you reduce it by 1. So if I write it again clearly, so the first part of your answer is 24 minus 1. And second part of your answer is 99 minus whatever you get, 23 here you got, no? You don't need that, right? So what this becomes 2 3 and this becomes 7 6, which is your answer. Combine them, you get your answer. Similarly, same thing follows for 422 as well, right? So you take 422 minus 1. That's the first part of your answer. Second part of your answer is 999 minus 421, right? Whatever you get out of 421, and then you get 9 minus 4, 5, 7 and 8. 4, 2, 1, 5, 7, 8. So it's easy, right? Easy, no? Some multiplication by double nine and triple nine. Okay, same thing can apply for 4 nines as well. The pattern will remain the same. So basically the first part of your answer subtracted by 1 and then subtract 99 from that, whatever you get. That's all it is. Okay. All right. So let's look at multiplication by 11. Now I've told multiplication by 11 is a very easy thing. So all you have to do is take the first digit, bring it down here directly. Take the last digit, bring that also down here directly. And then the middle digit is sum of these two, 264. That's all it is. So taking your first digit, bringing it down, second digit also bringing it down. That's put it on, either sides. The middle digit is what you get the answer. Now, if there is a carry here, this carry will go and sit on this digit. Okay, suppose sometimes when you do an addition, like 338 into 11, you will have 3, you will have 8, but in between 3 plus 8 is 11, right? So this answer will become, you write it like this. So this answer, this one will go here, 418. Okay, so that's property of multiplication by 11. But why it works is very simple, because 24 into 11 is as good as 24 into 10. We all know the answer, 240. And then one more, right? One more is multiplying by that, one more is 24. So when you add it, see, you get 264. You see these two digits always line up and add the middle digit, and the last digit will always be there because this will be a 0. So that's why multiplication by 11 is very easy. Let's look at multiplication by 101. When you multiply this by 101, you get 2323. Just repeats, the number repeats. That's it, 2323. So 33 into 101 will be 3333. That's it, it just repeats. Some problem you get and you have multiplication by 101, you're lucky, you know your answer in a milliseconds, you can get it, right? I have a few more examples with with carry. Let's see. So 231. Now there are 3 digits. Remember, the base is 100, so you're allowed only 2 digits. So this will become 231, but you'll have to write it like this. So this will add up. It will become, this 2 will get added up here, right? So 2 3 3 3 1. Similarly here, 121, you have to write it like this, 121. This is your answer. The answer you will get is 1 2 2 2 1. So easy peasy, all these calculations are for 11, 101, 9, 99. We can cover, basically when you go through an entire course of Vedic mathematics, you will have covered most of the shortcuts. There are some special methods that you can use. These are special methods, right? They are for special because you can get the answer without even writing. Mentally you can get it, right? Some other methods are a little longer methods, but general methods, that will apply for everything, right? The vertically and crosswise is a general method that you can apply even for this as well, but you don't need to use it, because if you do use the vertically and crosswise, you're unnecessarily going to complicate things. It is not required, right? It is not required because these numbers are very close to a base, so that's why it becomes easy to calculate all these, right? They're very close to a 10 or 100 or 1000, right? And multiplication by 1000 we all know, and we are taking advantage of that property and then making it easy for you. Okay, all right. Recurring decimal, interesting. This is recurring decimal is interesting. So if you might need to go through my classes, to my earlier recordings to really get a hang of it, but pretty much is one of the easiest examples around. So I'm going to take that same example that I've done before, right? 1 by 19. So a couple of things here to know when you're doing recurring decimal is a concept called the ekadika, right? Ekadika, yeah, ekadika. I hit it properly. Ekadika represents by 1 more than the number before 9. Okay, in this case, okay, the 1 more than the number before 9 is 1. 1 more than 1 is a 2, right? So for the ekadika of 19 is 2. The ekadika of 29 is 3. right? So this is going to be my divisor now. So I'm dividing 1 by 19. Instead of that, I will always divide 1 by 2. Okay, so now 1 by 19 is equal to, I will divide by 1 by 2 in this case, the very first case. So I put a 0. When I divide 1 by 2, what do I get? I get a 0 with a remainder 1, right? Now this is my new dividend. My first dividend was this 1 divided by 2, my ekadika. See, the thing is that the beauty of it is, the Vedic Maths is trying to simplify things for you. They say that, it says that, don't worry about dividing by 19, just divide by 2 first. I divided by 2 first, right? And I got this 0 remainder 1. Now take this is my new dividend now, 10, right? This is my new dividend, 10. 10 I divided by 2. When you divide 10 by 2, what do you get? You get a 5 remainder 0, right? Now again this pattern repeats. Now take 5 and divide by 2. When you take 5 and divide by 2, what do you get? You get a 2 remainder 1, right? Now take this 12 and divide by 2. You get a 6 remainder 0. And when you take 6 and divide by 2, you get a 3 remainder 0, right? And when you take a 3 and divide by 2, you get a 1 remainder 1, right? 11 divided by 2 gives you a 5 remainder 1. So you can continue like that. So you're actually generated your answer here is 0.0526315 that can continue on, right? So that's very simple and easy recurring decimal division. You find out the ekadika. First time you divide by 1 by 2 by that ekadika, then you get these numbers and keep dividing by that ekadika, you get your answer. Okay, now there's another thing that I will tell you, and let me calculate it. 7, I'm going on, right? 8 and 1, right? 9 and 0, right? 18 divided by 9 and 0, right? And when I divide 9 by 2, I get a 4 remainder 1, right? And then I get a 7 remainder 0, right? So what you can do is, you don't need to go all this way along also. What you can find out is, what is the difference between 19 and 1, right? 19 minus 1 is what? 18. Whenever you see a 18 here like this, you can actually stop, right? Then the remaining digits you can get by simply making it a summation of 9. See, 0, then you just subtract from 9, you will get your remaining digits. So 9 minus 0 is a 9, right? 9 minus 5 is a 4. 9 minus 7 is a 2. So you can guess what will be the next digit. 9 minus 6 is a 3, right? And then 9 minus 1 is a 8, right? 9 minus 5 is a 4. So this actually continues. So the thing is that even you don't need to do this division also, but once you find the middle way number, you can actually generate the remaining digits by yourself, right? Isn't that beautiful? Okay, so let's look at the second example. 1 divided by 29. Okay, what's my ekadika for this? My ekadika is 3, right? So I'll take 3 and divide by, uh, 1 and sorry, I'll take 1 and divide it by 3, right? 1 divided by 3, right? So I'm going to get, same thing, right? Now I take 10 and divide it by 3. When I divide 10 divided by 3, I get 3 with a remainder of 1. I take 13 and divide it by 3. When I do that, what do I get? 4 with a remainder of 1. So 14, I have to divide it again by 14 divided by 3. I will again get 4 remainder. So what am I dividing? I'm dividing 14 by 3, right? So I get a 2 remainder 2. Then 24 divided by 3, I get an 8 remainder 0. 2 remainder 2, right? 8 divided by 3, right? 3 2s are 6, 2 and then 2 remainder. Then 7 remainder 1. So this is how your answer is. Now you can keep going on until you get a middle number of 29 minus 1. if you get anywhere you get 28, you can stop there and generate the remaining digits. But you don't need to go so far, but I'm just explaining that you might be happy with getting 3 or 4 digits itself very instantly and very quickly. Okay, so this is applicable for this recurring decimal is applicable. This method is applicable where the series is ending in 9. You can also convert some numbers. Suppose you want to find out 1 by 7. You can also convert it to a series ending in 9 by simply multiplying by 7 on both up and down below. You get 7 by sorry. Oops. Let's see. Just give me a sec. Let's restart my pen tablet here. Yeah, so you get a 7 by 49. So now your Ekadika is 5, right? And then follow the same pattern. 7 by 5, you first divide by that, then you will get this. And then whatever you get the reminder with that combination of the digit, keep dividing by 5, you get your answer. So it's very simple and very easy to do, recurring decimals, right? So let's look at special division by 9, 8, and 7. So we are halfway marked to our session today. We have some more topics to cover. So I'm going to kind of crank it up a bit so that we finish by 6:30. That's our end goal. Of course, if you're watching this as a recorded session, you have the luxury of taking a break now. You can pause the session and maybe come back later. Okay. So special division by 9. Let's cover that first. Division by 9 is very easy, right? At least if there is a, in this case, when there is a 2 digits or 3 digits, we'll cover 3 digit 999 also later on. I have another slide of that. So when you consider division by 9, what you do is your first thing is you're finding the quotient and the remainder, right? So you bring that 3 down, right? This is your quotient. Your remainder is sum of these two. Your remainder is 4. That's all, right? Your quotient is 3. You bring that 3 down. Remainder is sum of these two. Now, if you get a remainder higher than 9, you got to give one back to the quotient. You got to give one back to the quotient. Okay. Now, division by 8 also follows a similar pattern. You bring 3 down, right? Your remainders, the only difference here is you double this digit and then add it. Okay, right? You double this digit. 3 into 2, 6 plus 1, 7. So that's how you get. Okay. Division by 7 is also easy. You bring that 3 down. Okay. You triple it 3 times. Make it 3 times. See, now if you see there is a pattern Y right here. 9 is 1 less than 10. 8 is 2 less than 10. That's why you're doubling it. 7 is 3 less than 10. So you make it 3 times. So 3 into 3, right? 27 plus 1, which is a 28. Now you got a problem here, right? You got a big reminder here, right? So you got to give away everything. Most likely, you end up giving off oh yeah, 3. No, I'm sorry, my bad here. I was not focusing, not 3 cube that I was trying to solve. So here is 3 into 3 is 9 plus 1, which is a 10, right? So 3 remainder 10. 10 can never be the remainder, so you give away 1 7. If you give away 1 7, you will be left with 4 remainder 3, right? That's all. That's your answer, right? So recap: when you divide by 9, bring that 3 down. The remainder is the sum of the both the digits. Okay. When you divide by 8, you bring the 3 down. The reminders, you double this digit and then add it, right? And a remainder by 7, you bring that 3 down, make it 3 times, add it to 1, and then if you have to handle the excess remainder that you have, give one back to the full 7. If you have a full 7, give it back to the quotient, and you get 4 remainder 3. All right. Okay, special division by 99. Now 99 is also very easy. Okay, so what you do is here 2, 3, 4, 5, right? So now you will have two digits. So let me draw a line here, 2 digits on the remainder. You have 2 digits here, you will eventually have 2 digits on your remainder. Okay, so I bring this 23 down. My other step is I simply add it to 45 here. So when I add it to 45, I get a 68. This is your answer. 23 remainder 68. Easy, right? 3 4 3 2 5, right? So what you do is you make pairs of 3, you bring the 34 down, you add it to, you add 34 to 325, you add it, what do you get? You get a 358. The answer is 34 is your quotient, remainder is 358. That's all. So the only thing that you have to take care here is you have to make it in pairs of 3. Find decide. Here you make it in pairs of 2, right? Here you make it in pairs of 3. This becomes effectively a 0, so that also you can consider as a pair of 3, right? You bring that 34 down, 0 34, add it to this, right? So that's how you get a 358, and this is your quotient. This is your quotient, and this is your remainder, right? So that's it. All right. So next topic is base division. Okay. Base division is similarly, kind of, there is a, slight correlation to what we're doing in base multiplication. Remember, we are looking at the base, trying to find out how much lesser or closer it is to the base, right? So that's how we do it. Now, I have some animation here. So let me just, an animation actually, let me just switch and show you, because I have some color codes, and just in the interest of, yeah, got it. Okay, so here we are dividing 1225 by 12. Okay, so the very first step is to find out how much it is less than 10. So I put with the minus sign here. Okay, how much is greater than 10, sorry, I put it with a minus sign. That's one thumb rule you got to say. Okay, if it's lesser than 10, you will put a positive sign, but if it's greater than 10, you will put a minus sign. Okay, so 1225 divided by 10 is what we're doing, right? So let me start from these steps here, right? So when I write it this way, right, this is my dividend, right, and this is my divisor. The very first step is I bring one down. Okay, that's sorted. I bring one down. My next step is I take this 1 and multiply by minus 2, right? When I multiply by minus 2, what do I get? A minus 2. I write that down here. Add these two together, I get a 0, right? Then I take that 0 and multiply it by minus 2. What do I get? I get a 0, right? That's it, right? And then I bring that down together, right? Now I got a 2. I take that 2 and multiply it by minus 2. I get a minus 4. 5 minus 4, 1. Your answer is here. Quotient is 102. Remainder is 1. So let me just do that quickly in like single line here. So what we're doing, 1225 divided by 12. Find out how much excess it is, right? And write that down here. You bring this 1 down here, right? You multiply 1 to minus 2. You write it down. Start displacing one digit after this. Skip this digit and write it here. Now do this operation, 0, right? Now take 0 and multiply by minus 2. What do I get? I get a 0. I bring this down here, 2. Now take a 2 and multiply by minus 2. I get a minus 4, right? That's it. Quotient, remainder. See how beautiful and easy it is to do a division, compared to that complex method that we have, right? This is quite easy, quite easy. So if you have, like, say, if your quotient was, if your divisor was 13, here it will be minus 3. That's all. Then you will always multiply by minus 3, right? That's all. All right. So I think I had one more example there. Yeah. So 1697 divided by 14, right? So let's do that. 1697 divided by 14. So how much it is this? Minus 4 is this, right? Minus 4 is the, so I'll bring that one down here, right? And then I multiply minus 4. I got 2. Take that 2 and multiply by this. I get a minus 8, right? 9 minus 8 is 1. I take a minus 1 and multiply by this. I get a minus 4, right? This is your quotient. This is your remainder. Fastest method. Fast, super fast method compared to doing this 1697 divided by 14. Just imagine the amount of time that you will take to figure this out. You're here with the answer in under 5 seconds. Under 5 seconds, you can crack this, right? So beauty of Vedic Maths. Beauty of Vedic Maths. Now, okay. So I was right there, right? Okay. I think I had one more example here. So now this is, if the number increases, if the number in the divisor increases, you will have a little more operations to do. But that's a given, right? Anytime you have more numbers, you would sometimes have more operations to do. Now the only difference here is, see this. You bring 2598 divided by 123. So 123. So minus 2 minus 3, right? How much it is less than 100? So the other easy way to do this is, right, 1 2 3 you have, you just take this number, bring it down and add a minus sign. That's it. You keep this on the side, you do it. Okay, so bring 2 down, first step is done. Then you multiply 2 and minus 2, you get a minus 4. 2 and minus 3, I get a minus 6. Okay, this first step is clear, right? When you do this, you immediately do 2 5 minus 4 1, right? Now I got to multiply 1 by minus 2, right? And I write it down below this in the next line. That's the only difference here, right? And then 1 by minus 3, and then simply do all that simple line up whatever is lined up. You do the operation. So 25 minus 4 is 21. That's your quotient. Your remainder is 98. 9 minus 6 3. 3 minus 2 is a 1. That's a 1. And 8 minus 3 is a 5. So that's your quotient and your remainder. Very easy. Very easy, right? All right. So let's quickly move forward. Let me come back to my main deck for today. All right. So we did all this short division. Like, so this was base division where it was closer to a base number of 10, or 100. Maybe, if the numbers is, 123, 134, but if it is 189, it'll be very, your multiplier will be long, right? So we have some short division methods in Vedic mathematics. Let's just do this. And again, it might help if you go through my earlier slides, earlier sessions. So you're dividing 212 divided by 52. So I will write 5 and 2. I put it on the flag. Okay, and then I draw one line here. This indicates any digit after this that I'm calculating down. This is where I calculate. Below this, I'm going to calculate do my operations. Anything after this is going to be my remainder, right? So I take 21 and divide it by 5. Forget the flag and everything else. Forget this 2 digits and everything else. Just divide 21 by 5. What do you get? 4. Remainder 1, right? Your remainder is 12 minus 8, 4. That's it. So this is your quotient and this is your remainder. So basically 22 and 2 divided by 7 is 4, remainder 4. Easy, right? Simple steps, right? You can't use the base method here because this is very far away from 10 or 100, right? Use this method. Use the the short division method, right? One more example. 312 divided by 43, right? Draw the line here. 31 divided by 4, right? Goes 7 times, right? Goes 7 times. So when you do 28, 31 minus 28, right? For 7 times you get a remainder of 3. So this one is 32 minus 21. That's your remainder. 1 1, right? So 7. Answer is 7. remainder 11. So very straightforward. So now this is the base short division method. Now go through the long division method now. Long division method by in the sense that you have more digits here. Okay, it is the same short division method only that you will follow, nothing different. Okay, it's just that you will do operations on few more digits, extra digits. 17496. So where will this is my flag, 7 and 2, right? 2 is on the flag. I will draw one line here. How many digits on the flag? That many digits I'll do. If there are 2 digits on the flag, I'll draw here. Mostly our goal is to keep this flag digit as small as possible. Okay, that's will make our calculations easy, right? Of course, you get now there are methods where even if I have 78, right? I will be having 7, 8 on the flag. But here, interestingly, what I'll do is I'll convert this to a vinculum negative number form, 8 bar 2. Right, 78 can be written as 8 bar 2, so my flag will become -2. Then it's easy to do the calculation compared to doing the calculation with 8, but just you have a negative sign, that's all. So but it's easy to handle that. Okay, so you can handle it that way as well. But let's cover this now. 7 with a flag of 2, 17 divided by 7, right? It will go 2 times, right, with a remainder of 3, right? Now your next step is multiply 2 into 2, right? The flag in this, you get 4. Subtract this 34 minus 4 and then divide by 7. So 34 minus 4 is 30. 30 divided by 7 is a 4, right? With a remainder of 2. 30 divided by 7, right? So 7 4s are 28, 2 remainder, 29. Now we got 29 here. Now multiply this 2 and 4, 8. 29 minus 8, which is a 21. 21 divided by 7, 3s are 0. Now you multiply 3 into 2, 6. 6 minus 6 is a 0. So your answer is 243, remainder 0. Okay. So that was easy, right? It will get easy if you practice more. Okay, so you can take your own examples, practice it more, and then you'll be able to get this will be something that will become thorough at some point in time, right? So this is just not worry about that. Okay, 50607 divided by 123. So now here I'm not going to put 23 on the flag, no way, right? That's going to make my complication, my addition much more difficult. What I'll do is I'll do 12 and 3 on the flag, right? 50607, right? I'll draw the line here, 1 digit on the flag only, right? 50 divided by 12, right? 4 with a remainder of 2, right? Next step is 26 minus 12. I get a 14, right? 26. Before I divide by 12, I have to subtract this 3 to 4, 12. 14. 26 minus 12. I get a 14. 14 is what I divide by 12. So when I divide, I get 1, remainder 2. Now 20, I divide 20 by 12. No, you have to, before you divide 20, take out this 3. So which is the 17 divided 12, right? It will go 1 time, 17 by 12 with a remainder of 5. The last step is 57 minus 3 into 1, which is a 54. So your answer is 411, remainder 54. Hope it was easy. I got it through, right? Simple pattern that you're repeating itself. Divide, multiply, subtract, again divide, multiply, subtract. Okay, squares. So a lot more to cover today, right? I know it's a little bit overwhelming, so you don't need to look at the session in one go. You can actually pause it, if you want to, if you want to really practice one topic a day or 2 topics a day, that's also well and good. Over a period of time, you're going to master all these topics, right? So square of 42. So there was a duplex method we discussed. Okay, the duplex method is where you take first find out the duplex of 4, which is a 16, right? Then you find out the duplex of 4 and 2. See, remember the duplex of a single number 1 is 1 squared, which is 1. Duplex of a double number 1 and 2 is twice of 1 into 2, which is a 4. Duplex of a 3-digit number is 2 into 1 into 3, the outer pair, plus square of the middle inner pair, which is a 4, right? So which is a 10, right? So that's how you find duplexes, and we're going to use the squares effectively is the sum of all the duplexes. If it's a 2-digit number, you find the duplex of 4 first, which is 16. Then you find the duplex of 4 and 2, which is, you see, what is 4 and 2? Double the product, right? So 4 into 2 is 8. 8 into 2 is 16, right? I write it like this. And then I find the duplex of 2, which is a 4. So my answer is 1764, the square of 42. Easy, right? (53 squared). So I start with the duplex of 5, which is a 25. Then my next digit will be duplex of 5 and 3, which is 5 into 3, 15. Double of 15 is 30. Then I find the duplex of 3, which is a 9. So my answer is 2809. So I'm instantly able to get my squaring, right? It's a super fast, easy method, right? You can also deploy your sutra as well, 53 into 53, and find it out. But I think this is faster. Duplex method is definitely faster, right? You can also use the base multiplication method here. Your base will be a 50, right? So plus 3, right? So only thing is, when a base is 50, what you do is you have to multiply it by a 5, right? So this becomes a 9, 0, 9. 53 plus 3, 56. So this becomes just a 9, right? 56 into 5, which is a 280. 280. Why am I multiplying it by 5? Because my base is not a 10, my base is a 5. So you crosswise, you add it, 53 plus 3, 56, multiplied by 5. It was 40, you multiplied by 4, right? Then you get that answer. 9, just 3 into 3 is 9, because your base is tens, so there's no need to do you no need to put 2 digits, just 1 digit, and that's how you get your answer. But see, this is faster because here you have a multiplication by 5, which is sometimes bigger number, right? Multiplication by 5 is not very difficult actually. Multiplication by 5 is where you simply add 1 0 and half it, right? 560 divided by 2 is 280, right? Okay, cubes. Interesting, cubes. So in cubes also we follow a very similar pattern like the duplex, right? So first triplex, it's something called the triplex. Yeah, 3a squared b, 3ab squared, and b cubed. This is for a 3-digit number, right? All you need to follow this, add all these triplexes together, you get your answer. So let's check it out. What is a cube? So now a represents 2 and b represents 1, right? So a cube is 8, right? 3a squared b is 4. 2 a squared is 4, no? 4 into 1, 4 into 3, 12, right? 3ab squared, right? That is 3 ab. So let's calculate ab squared and make it 3 times. That's easier, right? So ab squared is 2 into 1, right? 2 into 1, which is 2. 3 times of that is 6. And then b cube, 1. So the answer is 9261. That's your cube, right? In the duplex method, you're following a squared, 2ab, and b squared. Simple formula of a plus b squared. A squared plus 2ab plus b squared. That is what you're solving, you're using to solve your squares, right? Isn't it logical, right? So this is your first duplex, second duplex is this, your third duplex is this, right? Now if you have 3 digits, you will follow a plus b plus c squared ka formula. That's all, right? But the idea is not for you to memorize any formula. The idea is for you to understand the concept. That's why I never told about this formula before, right? There's no need to do that formula. All right. So we are at square root now. So square root this is perfect square roots, right? How you calculate perfect square roots? 1849. So when you have a square root, divide it in pairs of 2, right? And first find out what is the closest number which will be a square of this, right? This is obvious that 4 will be the closest number, right? 4. Double that 4 and keep it on the side. Okay. Now what you do is, let me write that number here, 1849, right? Now you know 4s are 16, right? So you have a balance of 24, right? You take 24 and divide by 8. Okay, that's your next step. You get a 3 with a remainder of 0, right? You actually got your answer. It's a perfect square, 2 digits, 43 is your answer. That's it. You can keep doing it again, right? You have 24 divided by 8 is you got 3. Now you take 9, and before you divide it by 8, you need to find out that subtract the duplex out of this. See, this is a reverse of the squaring method. Okay, so that's why you're doubling this. If you see a squared plus 2ab plus b squared, you are doubling this and keeping it on the side. That's a reverse of it. I won't know in detail, but just follow this pattern. So first you take 1849, take the closest number, which is which single digit is closest to 18. It is 4. You get a balance of 2. 24 divided by 8, you get a 3, right? 9 minus the duplex of 3, which is a 9, which is a 0. 0 divided by 8 is a 0, so that's how you get a 0. You can keep doing it, and that's what you'll get. Okay, another number, make pairs of 2, right? Here the closest one would be what? 3, right? 3 3s are 9, right? So 1 3 6 9, right? Double 3, you get it, keep it on that side. Okay, double 3 and keep it on the side. That's 6, because that's going to be a divisor. When you found 3 squared 9, 13 minus 9 is 4, no? 46 divided by 7. That's what you do first. You do that, what do you get? 7s are with a remainder of 4, right? Now next step is, you already got your answer, because you are expected only to get 2 digits. Right here you got your 2 digits. 37 square root of 1369 is 37, right? You can do again one more step. 49 minus the duplex of this, 49 minus 7 squared, and then divided by 6, right? So what is 49 minus 7 squared is 0. 0 divided by 6 is 0, right? That's your answer. So let's do cube roots. This is perfect cubes. Okay, so you don't have much calculation here. You have to just remember this table here. With this you can derive cube roots just by simply looking at the last digit. So if the last digit is ending in 2 3 7 8, right, of the cube, whatever you're trying to find out, the resultant answer will also the last digit of the cube root will be 8732. You can memorize this, but I'll give you an easy trip. If you add these two, you'll always get 10. So whatever you're getting 2, last digit will be 8. If you're getting 3, the last digit will be 7. And now if the cube is ending in 1 4 5 6 9, the last digit of the cube root also will be 1 4 5 6 9. So easy with this. With a single digit, you can just look at the last digit and figure out what your cube root is, right? See, look at this example. 8, here 8, the cube root is 2. 27, the cube root is 3. 64 is 4 only, right? Because I told you 4 and 4, right? 5 and 5, 6 and 6, 7, see 7 3, right? 5 and 2, 2 and 8. Now this is not a single digit. Now what if you have bigger digits, right? So very simple there also. You keep this in pattern here, in pairs of 3, right? So you can guess the last digit automatically. This is, so there are 2 digits in the cube root. Last one is 7. So remember, when it was a 7, then it will be a 3, right? Remember, when it was a 7, the last digit will be 3. So you already got one part of your answer. Now 12 is the first part. So which is the closest here to 12? It'll be a, what's the closest here? So it will be 8, right? 8 and 27, right? So your first part of your answer is 2, right? Because 2 cube, 20 cube is 8,000. 30 cube is 27,000. Your answer that you're trying to find out, 12,000, is somewhere in between these. So you know that it will not be a 3, it will be a 2 only. This digit you already derived it, right? You already derived this digit, so it's easy for you, right? Similarly, cube root of 3, 309. Oh, we are almost at the top of the hour, and Yeah, we'll kind of wrap it up now. 2 digits here, right? So 4 means it will be 4 only, right? 39, you can guess it. It falls between 27 and 64. So your first digit will be a 3. 9, if the last digit is a 9, the cube root also will end in a 9, right? 205, where does 205 fall? Between a 125 and a 216. So this will be a 5. So you simply solved cube roots perfect. Now there is a method for solving imperfect cube roots also, but that's a long method. I'm not going to go through that. We didn't cover it in our sessions. Just perfect cube roots for now. Okay. Okay, instant subtraction. We're kind of almost done. Here we use the concept of the bar numbers, right? Normally when you do a subtraction and when you have a small number, you have a large number, you try to carry one from here, right? There's a lot of carry, sometimes it gets messy. Now, what I'm telling is just don't do anything of that sort. Simply do a bar sign here, 2 bar, that's all. If this is a small number, if you're doing a small number minus a big number, you just do it 7 minus 5 and put a bar sign. That's the only condition. 7 minus 6 and a bar sign, right? 5 minus 3 is a regular without any bar sign, 1, 0. So this, now if you see, this problem is simply 200 minus 12, right? And if you remember the sutra that we did for all from 9 last from 10, right? This is exactly 200 minus 12, right? You can subtract it. All from 9 last from 10. You reduce this digit, it goes by 1. 9 minus 1, 8. 10 minus 8 is 10 minus 2 is a 8. That's your answer, right? So 01888. So here again 2 bar, 9 minus 6 is a 3 bar, 5 minus 8 is a 3 bar, and 4 minus 2 is a 2. So then apply the sutra directly, right? All from 9 last from 10, 1, and 9 minus 3 is a 6, 6, and 10 minus 2 is a 8. This is your answer. You will get this faster than doing all those carries. Concept is almost the same, there's nothing different, right? It's fundamentally subtraction is subtraction. Here you're cleverly using this method of you're using this bar number sign and then trying to solve the problem. Okay. So percentage calculation is the last topic. We're almost there here. So this is also simply using the sutra vertically and crosswise, right? So when you do 12% of 92, it's as good as doing a vertically and crosswise. The very first thing that we did, and that's why I'm ending it with this as well, vertically and crosswise. So when you do a 2 into 2, right, you get a 4, right? Remember the vertically and crosswise method. So 2 plus 18, 18 plus 2, 20, right? 2 plus 18, 20, 9, right? So what do you get? 1104, right? Divide that by 100, that's your answer. So your answer is 11.04. This is your answer, 11.04. You will divide by 100. 23 into 63. Similarly, do that same thing. 9, 2 into 3, 6, 18. 18 plus 6, right? 24, right? 6 into 2 is 12, right? So what do you get? 14, 49. 14.49 is your answer, right? So imagine doing all this in a jiffy, right? 23% of 63. You might find it difficult. It tells it's a little overwhelming, to do this. So I think with that, great. I mean, this was a marathon practice session. I've never covered so much in one session myself, but the idea was to pack as much as possible information for you. We've covered all these topics today, and just getting back to the topics. Yeah. Yeah, we didn't cover Pythagorean triple and divisibility check. I'm sorry about that, but I think you can just check my videos on that because it was difficult to do a lot of these practice. We kind of almost did 32 problems in each, so it's almost 30 problems in 1 hour is not easy, right? So thank you for your time. It was good having these sessions on YouTube. I hope you enjoyed. These sessions are always available for you to go back and refer. Make good use of it. Do practice. Practice makes you perfect. And I thank you very much for watching my videos. Do like and share some comments if you feel that's appropriate. Okay. Take care then. Bye bye.